Is he?
Yeah, he's here.
Oh, welcome.
Can you hear me, guys? Yeah, good. Well, actually, this is the wrong version of slides, so I'm not going to use slides at all. So let's try without slides, which is kind of new for me. I've never done this before, so let's try it first time. This is enough to know about my presentation. My name, just my name, and the title. So the question is, for how many of you continuous integration actually works? Can you raise your hand? Yeah, good. So now I'll try to explain, we're going to discuss why it doesn't work for you. And so first of all, a few words about what continuous integration is. I'm a software developer myself, a software architect, so this is what happens in my project. When we have a software project, no matter how small or big it is, it usually consists of elements, of modules, which has to be connected to each other. And there are usually a group of people working with these modules. And the problem is that when we start working on them separately, I work on one module, you work on something else, they have some connection between each other. They work together. But then we start working on them, we start making changes to them, and then we bring them back in a few days or in a few weeks, and they don't fit together. They just don't fit, they don't connect, they don't understand each other, we have problems, we cannot integrate them. That's why the idea of continuous integration was proposed, I think about 10 years ago or something. The idea is that every time you or me makes any changes to these pieces, we connect them immediately. We don't wait until it's ready. We don't wait until everything is finished and you're ready in a few weeks with your module and you bring it back and integrate with mine. We just integrate it every time you make some changes, or I make some changes, or anybody in the team makes any changes. So we continuously integrate many times a day, many times, maybe sometimes many times an hour. So we bring, every time anybody makes changes to the pieces of code, we continuously build everything. We try to put these pieces together. Well, if the build is automated, then we run unit tests, we package everything, we try to maybe deploy something, we maybe try to release something. But the point is that we don't wait until everything is ready. We just put pieces together continuously, many times a day. That's the idea of continuous integration. And it sounds good. And this is the main problem the continuous integration solves, is actually it prevents the situations when it's too late to integrate. That's one thing. And another thing which continuous integration helps to programmers is actually that programmers know that every time I'm getting all the code from repository, I know that everything is integratable. So all the tests are stable and everything is buildable together. So I know that when I start working with this code as a developer, I know that, well, all the tests pass. So the build is clean, so-called. This is a good thing for me as a developer if I'm working with the project where continuous integration is set, is configured. So I join the project and I know that it's not broken, it's more or less integrated continuously. So I know that a few hours ago, maybe a few minutes ago, some machine, some server, which is called continuous integration server, or service, something like some machine basically, actually tried this code to integrate it together, and it was buildable. So it's clean for me. So I can make changes and see how my changes fit in. So if my changes break something, then everything breaks, and I know it's my problem, not the problem with the code. So that's a good something which I get as a developer when I know the continuous integration is there. And it sounds good so far. That's the theory. That's how it should be. And in reality, it doesn't work. So all the books, all the theories, all the articles, all the presentations probably you've heard before, they say that, not maybe the presentations not, but all the books I've read about continuous integration, they say that when we try to integrate this stuff together, we try to build everything after the change happens. If it fails, let's say I make the change, let's say you work on some piece of code and I work on some piece of code. You make some changes there, you bring these changes back to our repository, and we can't integrate it because you made something which is not a good fit for my code. Then at that point of time, we have to stop and fix that. So you have to probably get back this code to yourself, make the changes, and make sure that actually the code doesn't break the whole thing. So we cannot continue to work, I mean 2 of us, if it's a group of 2 people. Then if you make some changes which breaks our code, then we cannot continue. We need to stop. I mean, we, 2 of us, we need to stop and do something about it. Maybe remove your changes and roll them back, or improve something, or fix the problem, but do something with this problem. And it sounds, this is what the books say, and it sounds good if there are 2 people in the team. But if there are 20 people in the team, and imagine one guy breaks something, then 20 people have to stop and wait until the problem is fixed. That's what the books recommend. And that's what doesn't work. First of all, they're basically, I'm not sure whether you see that in your practice, in your projects, but I do see that in mine. So I know that it's impossible to stop a team of 20 people from continuing to work when one guy breaks something. So there are possible basically two solutions. I mean, two existing ways of solving that, of not solving, but the 2 workarounds of what may happen. The first case is people just start ignoring that. Okay, this guy broke something, there are 20 people working, we can't just stop and wait until it's fixed. So we just continue working, and we have the broken build. We have the repository which has something broken. So continuous integration is no longer integrating anything. It's just saying us, it's broken, it's broken, it's broken, and the whole team continues to work. This is what's happening in most cases I've seen so far. So we do not actually use the information from continuous integration server, which is supposed to tell us, stop. This is, time for you to do fixes. You cannot continue to work. You need to stop. But we don't stop because it's against our, business objectives. It's against our. This is not what business pays us for. The business wants us to continue to make, to introduce new features, to do development, not to wait for some fix of some broken unit test introduced by some guy who is like one of 20. So we just cannot stop. And people don't stop, the teams don't stop. And this continuous integration becomes just another nice, cool tool, which is fancy, which is so good looking, which is so modern, and everybody wants to use that. But in reality, it doesn't help at all. It just gives us information about your build is broken. Okay, it's not broken now. Again, it's broken. It's just information flag, information signal, which everybody just ignores. That's one case which I've seen a lot. Another case is that people saying that, we're not going to ignore it. We're going to pay attention to this signal. We're going to really care about this continuous integration flag, which is red or green. And we're going to find who is that guy who actually breaks our build. And we're going to not punish the guy, but we're going to do something with this person and these people. For example, we're going to say that if you break the build, you have to fix it immediately, or you have to stay after hours, or you have to fix it today. This is I would call it the blame culture. So the team starts to blame these programmers for introducing not high quality code. So if you make some changes to the module which you worked on, and then you bring this module back and it doesn't fit, then it's your problem, you have to fix it immediately, we're going to wait for that, and we're all going to look at you and give you bad looks because you did that. And that's how, for example, I've read, again, many articles about that, and it's a famous story that Microsoft, for example, they even had some kind of a hat, specially designed hat, which they were putting on these people who broke the build. So if you break the build, you get this hat, and you're supposed to wear this hat for the rest of the day. So it's not directly like a blame, but it is a blame culture. So we are putting these programmers into the position where they are starting to afraid to break something. So I don't want to break build. I don't want to wear this hat. So I don't want to be the guy who is the bad guy in this team. So that's why I start to be afraid of making changes. It becomes a fear-driven development, so-called. So the fear is what drives me. I don't feel comfortable anymore to make changes the way I want them. I always worry about not to break the build. I don't want to break it. I don't want this continuous integration server to raise a flag on my change. So I change something, and then everybody will see that the flag became red after my changes. And that's how we start to blame people, and this is this leads mostly in most cases, to slow development. So people start to become too careful and they wait for too long before returning back their code to the main repository. So they're trying to make it so perfect, so clean, so that it doesn't break the main repository, the master branch, that they never return the code. The code just stays with them for a day, for a week, for months, and then they say to the manager, you know what, it's so old, my piece of code, that there is no possibility for me to merge it in. Because it's so old, it's almost expired, so how about I start from scratch? And you keep paying me for that. So that's what's happening, yeah, and I've seen this a lot as well, a lot in many projects. So the intention is good, they want to deliver good code, but they can't because they're afraid to break things, and that's why they need to wait and make it perfect and make it perfect. But when the development is intensive, when we're making a lot of changes to the repository, then this branch, this piece of code, this module, becomes so outdated, so old, that there's no possibility to put it in. And we just throw it away. So in the end, we have throwaway code, which is waste of time and money for us. So we basically waste money for this development, we create something which is no way we're going to merge in. So this is what continuous integration leads to. There are two possible scenarios, and both of them are bad. The first one, like I said, is nobody cares about this continuous integration. It's just waste of time, waste of money for this server, for this configuration. Nobody cares about it. The second option is that we are creating the blame culture. So that's what I've seen. But there is a solution. So here's what I'm going to suggest. So I think the solution is so-called pre-flight builds. How many of you heard about this pre-flight build term? Pre-flight build. Good. A few people. So I hope in the end of the presentation will be 100 people know about that. So pre-flight build is the technique which says that before you put your code into the main repository, we have to test it and reject if it doesn't fit. So in traditional way, the continuous integration says, put your stuff in, as soon as it's ready, we're going to test it here. If it works, okay. If it doesn't work, we're going to raise a flag, we're going to stop and fix your stuff. This is traditional setup. The new setup with pre-flight builds is that you bring your stuff in here. We're not going to put it there. We do not allow you to put it directly to our main storage, to our main repository. We're going to test it before. We will have some special server for that, which will get your stuff, try to test it, to see whether it works. If it works, we're going to put it there, and then the guarantee that it's going to be green flag always is way higher. Because you're not going to break stuff. Because if you break stuff, we're going to reject it before you put it in. So there will be no blame for you. So you will not be afraid of breaking stuff because you know that there is a server in front of you which tests your stuff, and if it's not good, it immediately rejects it to you. So nobody's going to see that. Nobody in the team will see that you created something which may potentially break the main branch. And that's the beauty of it. So we completely remove the blame and the fear and all this bad stuff from the development team. Because now every programmer works in front of a server which does this pre-flight build. So it's called pre-flight because we test it before you fly. So before your stuff goes and flies into repository, we test it here. If it doesn't work, we just return it back to you and say, no, it's no go, please fix here and there. But nobody knows about that. This is just you. This is information just for you. You make some changes, you push it again it says no. You push it again no. On the third attempt, it goes okay, and then it goes to the master branch, to the main repository, and nobody's going to blame you for breaking stuff because you will not break stuff. That's the concept which we tried in our teams for 2 years already, and we see a lot of good stuff coming out of that. So with these pre-flight builds, we created a server for that. We created a number of technical solutions. You can do it yourself. It's not so difficult. You can even use Jenkins for that, plus a few plugins. You can use some cloud solutions for that. It's not so difficult. The point is that you need to understand the concept that we should not allow programmers to put their stuff directly to master branch. This is wrong. This is scary. If you allow programmers to put their stuff into master branch, they will be first of all afraid of breaking, and they will not be productive in their work. So the continuous integration as a concept will not work, and will have, like it says, will have negative effects. So that's probably it. That's what I wanted to say. If you have questions, ready to answer? Have you, yeah, great question there. I think you have to shout.
Okay, fine. So we have a particular server for each developer, or do you have just single required?
Yeah, we have, the question is, do we have servers for each developer, or we have a central server for this pre-flight build? In our case, it's not even a server, it's a service. So it's a hosted solution, which is on the internet, a cloud solution, and it's centralized. It's one for the project. So all developers, first of all, of course, they have their local builds, but they're not pre-flight builds, just local builds. So when I get the stuff from the main repository, I make my changes, I test it locally, and then I'm trying to push it there. I mean, give it to the repository, and then the server, the centralized one, who is responsible for pre-flight builds, it takes my code and says, okay, give me a minute, I'm going to test it, and if it's good, I'm going to put it to the master branch. So I'm not allowed to do that. It's not my server. It's a server which I even don't have access to. So it's a pretty isolated machine or pretty isolated service, which is quite, because people aren't going to like it. Most programmers will kind of complain about it, like this server complains too much about my code. I really want to put my stuff into master branch, but eventually they will realize how productive it is in the whole working environment. So the answer is this is the centralized, it has to be a centralized machine or per project. In one project it has to be centralized solution which tests all the builds pre-flight.
Why should it be centralized? Furthermore, there might be those changes also involved in database automation and stuff that cannot always be averted. So will it not on this server save those other problems?
Well, yeah, you're right. Definitely, if the project is too complex and it has to be and there are like database involved and a persistence layer, and there has to be changes for the persistence layer, which needs to be in parallel versions, then it's just a matter of how well you configure this server, how professional you are to configure it the way that you actually can test in parallel branches. So my code, my changes, you test it against some persistence layer, against some database schema, and then your code you can also test with the different changes. So it's just a matter of configuration. It's possible. We've had projects with a complex database schema, and it's still possible to make it in parallel branches. So we can discuss it later as well. Yep, go ahead.
What happens to the developers working on a module? Thank you. What happens when developers working on a module which is used in a long list of dependent products, and committing a new change to this module can possibly break any of those dependents? Does the pre-flight build have to figure out all the dependents of the change and build the whole suite of dependent projects before the developer can start breaking anything anywhere?
It's just a matter again of your configuration of the build. So definitely the pre-flight build has to be as powerful as continuous integration build. So you have a repository, you have some automated build configured, and the build includes other dependencies. For example, let's say your project depends on some library which is developed by another group of people, and then you build your stuff and you always involve this library. It has to be involved in order to check how this whole code works with that library. So when I change something here, then definitely the pre-flight build has to simulate the entire build. So the pre-flight build has to do everything as a normal build does. It has to be identical, exactly the same.
My question was more about the dependence of what someone is working at, because if you're working on a module which is used by 10 products,
yeah.
Building the whole suite of products of the company to figure out if everything still works might take hours, and that might slow down the whole process as well. To figure out you're not breaking something upstream.
Oh, so you're saying that pre-flight build may be too long?
Yes.
Yeah, that's true. That's a possible problem. If the pre-flight build is too long, it means that the normal build is also too long because they're identical. And if your build is too long, then definitely you will have a long waiting line of developers. So developer will create some changes and they will wait for this pre-flight build. If it takes like 2 hours, then developers will complain about it, definitely. And especially that if you have many people working at the same time, then all your pre-flight builds will stay in the line. So they will be sequential. you cannot run them in parallel. That's another problem with the version control system, Git for example. So you cannot do them in parallel, and that's a problem. So if the pre-flight build is too long, let's say it takes 2 hours, then you will be able to potentially commit like 5 changes a day maximum. From any team, the team has 40 programmers, you still can commit just 5 changes a day because each build is 2 hours. In that case, you have a big problem with the build. So the build, as all the books recommend, have to be less than 15 minutes. Ideally less than 5 minutes. So the build has to be fast. So if the build is too long, then the pre-flight build is going to make the situation even worse. So this is the answer. So you try to keep your build small. And if you can, then there is something wrong with the repository. Probably the repository is too big. So like all these stories with them, sometimes again from Microsoft, I've heard that they have some builds of 6 hours long. This is just a wrong design. It doesn't say that the team is so great that they can manage such a big project. It's just an indicator of the team is so bad that they cannot break this project into smaller pieces. So that the properly organized repository has to be built in less than 5 minutes. If you can't do that, then work on the repository. We have time for one more question. Yeah.
You talked mainly about code integration, but this is rarely the case. Usually you have to integrate schema changes and also data changes. So whose responsibility is to write migration script of the data? So you have old schema, old data, and you need to migrate it to new schema with the new data. And when this happens in this process?
Yeah, it's a good question. So again, you have to be able to configure your build so that it takes database changes and it takes into account as well. How to do that? There are different technologies. Let's say Liquibase, for example, is one of the tools which many people use for making database changes incremental and traceable. So I've tried, for example, Flyway, another tool which is also used by programmers for tracing, for making database changes incremental, like I said. So you can see that your database, for now, the MySQL database, the schema in the MySQL database is in version 1.7. And then tomorrow it's going to be 1.8. So not so many people can do that. I don't think many of you can actually say that your database schema has certain version right now. You know that your code has certain version, maybe, but you definitely don't know, most of you don't know what is the version of my MySQL schema right now. So I just have a schema, I just have 15 tables over there, and they were created half a year ago. That's all I know about it. If I want to change my schema, I just go to the database, make some SQL update or create table, or I don't know, update table request, and that's it. So we don't know what is the version of our schema, but we need to. If you can configure that way, so we can actually not only versionize the code, but also do the same with the schema, then everything will become more, everything will become doable. So you will be able to not only integrate, like you said, you're right, not only integrate the code, but integrate the changes to the persistence layer. So again, there are tools for that, and they're for years on the market. Just try them. Liquibase is one name, Flyway is another name. I was using Liquibase. So we're out of time. Thanks for listening.